All right, science fam, we have a neutralization reaction, which means that an acid and a base react to make water and some type of salt. So whenever we're doing these problems, you have to think about what's the acid, what's the base, and then figure out kind of how much of each is mixing together to neutralize it. So number 49 here says, how many milliliters of 0.2 molar sodium hydroxide is needed to neutralize 100 milliliters of 0.1 molarity hydrochloric acid? All right, so first of all, the question is we want to know how many milliliters of sodium hydroxide, okay? So because of that, we are going to be looking for the volume of the base, because anything with a hydroxide on it means that it's going to be a base. Now, we do know something else about it. We do know that it has a 0.2 molarity for sodium hydroxide. So if you remember, molarity is moles per liter. Capital M stands for molarity, and that's going to be the molarity of the base. Now remember, molarity is just a concentration. It's telling you how many moles for every liter of that liquid solution. All right, now we also know a couple other things. We know that there's 100 milliliters, it says in the problem, of hydrochloric acid. So that means that there is a volume of 100 milliliters of the acid. And we also know that the concentration, or the molarity of the acid, is 0.1. So now we have the molarity of the acid. Now, looking at this reaction, it is going to be a 1-to-1 ratio, but really quick, let's just double check. If hydrochloric acid and sodium hydroxide react, we know it's going to be a double replacement reaction. So that means that hydrogen is going to react and grab onto the hydroxide, which is going to make it H2O. And the sodium and chloride are going to come together to make sodium chloride. And when you do that, you'll notice that it automatically balances out. So what does that mean? That really means that for every 1 mole of hydrochloric acid, 1 mole of sodium hydroxide is going to be used to react. Because of that, we can use a very straightforward equation, which is the molarity of the acid times the volume of how much acid you have is going to be equal to the molarity of the base times the volume of base in order to neutralize. Because we have that information, we can plug all that in, and eventually we're looking for the volume of B. So this is what we're going to solve for. So let's plug and chug. So for my molarity of my acid, it's 0.1. For my volume of my acid, it's 100 milliliters. And don't worry, you can leave it in milliliters as long as your answer for volume on the other side is milliliters as well. And since we're solving for it, no problem. Our answer for the volume will be in milliliters as well. As for the molarity of our base, that is 0.2. And we do not know the volume of the base. That's what we're looking for. All right, but if we do that math super quick, 0.1 times 100 really just gives you 10. And that's going to be equal to 0.2 times the volume. To get volume all by itself, I'm going to divide by 0.2 to each side. And when I do that, the volume of my base is going to be equal to 10 divided by 0.2. And when you do that, it ends up being 50. Now the question is 50 what? 50 liters, 50 milliliters. So I'm just going to double back and check really quick. What was my initial volume in? It was in milliliters. So therefore, my answer is going to be in milliliters as well. All right, so as simple as that. You've got your volume is 50 milliliters. That's how much it will take of the base to neutralize the original 100 milliliters of hydrochloric acid. Now, if we jump to question 53, I think you're going to see that it's a similar setup and situation. You have 3 milliliter sample of nitric acid, and it's going to be perfectly neutralized by a volume of a base, which is potassium hydroxide. So first of all we know about the acid is that we have 3 milliliters of that acid, and that's called nitric acid, HNO3. So because of that, I know my volume, and I'm going to label this VA because I know it's a volume of the acid. Now, I I want to eventually know what the molarity of nitric acid is. So I am looking for the concentration or molarity of the acid, which I do not know. So that's going to be the thing that I'm really going to be looking for. Do I know exactly how to do that yet? Not necessarily, but I'm not panicked. I'm just writing down the information I need and that I have. And from there, hopefully, I can take those steps forward to help me out. Now, I do know that I have 6 milliliters of potassium hydroxide, and anything with the hydroxide on it is going to be my base, which is why I'm going to call that VB, volume of B. And I also know the concentration is 0.5 molarity for potassium hydroxide. So that is going to be my molarity of B, which is my base. All right, so that's the only information I have. Now, if I check really quick, nitric acid neutralized by, oh, someone's here. Forgive me. Nitric acid reacts with the neutralized by potassium hydroxide. You're going to see that that hydrogen is going to combine with the hydroxide to give you H2O. And then the potassium is going to combine with the nitrate to give you potassium nitrate. And look, once again, everything is going to end up being already balanced, a 1-to-1 ratio, which is a beautiful thing. Why? Because we can then use this equation. The volume of A, times its molarity is going to be equal to the molarity of B times the volume of B. Now, since there's a 1-to-1 ratio, we can use this equation, but if it's not 1-to-1, then we might need to do a little bit different style math, which is what other questions are like, including question number 41, which I'll get to. But I wanted to start with the more straightforward question first. So let's take a look at that and plug in and chug out the answer. So what am I searching for? I'm looking for the molarity of nitric acid, which is Ma. So remember, that's what I'm solving for. So I must have all the other pieces of information. So let me search that out. The volume A is 3 milliliters. The molarity of B is going to be 0.5. And the volume of B is going to be 6. All right, so the only thing I'm solving for here is Ma. So if I do that math, and basically it's just going to be 1/2 times 6, which really is just 3, right? And forgive me, I'm running out of space a little bit here, but that's going to be 3. And if I divide this 3 over to the other side, 3 divided by 3 ends up getting me a molarity perfectly of 1. So what does 1M mean? Well, let me make sure I label it properly. It is the acid, so that's nitric acid, HNO3. So it's a 1 molar solution of nitric acid. So what does that mean? It means you needed 1 molar acid, and how many milliliters of it? 3 milliliters of it, to mix with double 6 milliliters of the potassium hydroxide in order to perfectly neutralize it. All right, since there's different concentrations, it's not always exactly the same amount of volume, which is why you needed half as much nitric acid and twice as much of the potassium hydroxide. But hopefully, using that equation when it's a 1-to-1 ratio will help you out and make that more straightforward for you. All right, so to finish, I'm going to go with number 41, and unfortunately, it's not going to be a 1-to-1 ratio, so that MV equals MV isn't going to really work out for us. In fact, if you balance the equation when you read over this between sulfuric acid and sodium hydroxide, it says for every 1 mole of sulfuric acid, you need 2 moles of sodium hydroxide. So what does that mean? That means for every 1 mole of sulfuric acid, H2SO4, you need to use 2 moles of sodium hydroxide. And if you take the time to write out that balanced equation, H2SO4 plus NaOH, and it gives you water on the other side and the sodium sulfate, you'll find that you have to balance it out. You're going to need twice as much of this sodium hydroxide than this sulfuric acid. But anyways, let's see what we have here. We want to know how many liters of sodium hydroxide. All right, so I want to know how many liters of NaOH is it going to take? So that looks like the volume B for me, the volume of the base. How many liters? And we know that it has a molarity of, whoops, let me write that out, MB. 1 molarity, or it's a 1 molar solution of sodium hydroxide. So that is your concentration, which again means it's the molarity, MB. All right, what else do I know? I know that I have 1 liter of sulfuric acid, H2SO4. So that is my volume of A. All right, and I know that I have a concentration that is 1 molarity for sulfuric acid. So that is going to be my MA. Whoops, not my B, my A. All right, so now I have all this information, but in the end, all I really want to know is how many liters of this base do I need to neutralize it? So let me move this work up so that we can get down to business. All right, so step 1, if I need to eventually get the volume of B, and I know this relationship that for every 1 mole of sulfuric acid, there's 1 mole of sodium hydroxide, the first thing I need to do is figure out how many moles of the acid I have. Why? Because then I convert that into moles of base. And once I know moles of base, I can finally figure out the volume of base, okay? So step 1 is figure out how much acid we have. And how can we do that? Well, we know the molarity equation is the moles divided by the liters. So if I want to solve for the moles per liters of the acid, I already know some of this information, right? For MA, I know that there's 1 mole. If I'm searching for the moles up top, that's what I'm going to solve for. And my liters on the bottom for the acid is 1. So when I do that and I solve for X, which is just going to be 1 times 1, what ends up happening? I have 1 mole of this acid, okay, which is, again, sulfuric, H2SO4. Now that I have 1 mole of sulfuric acid, I'm going to take that and I'm going to convert that into how many moles of sodium hydroxide that would be. Now I'm going back to dimensional analysis. You may have written it a slightly different way, the way you do it, but I want to cancel out my sulfuric acid, so I put it on the bottom. I want to solve for what I'm looking for, so I put that up on top, which is sodium hydroxide. Now looking at my conversion factor, there is 1 mole of sulfuric acid for every 2 moles of sodium hydroxide. So that's why I'm going to put 2 moles of sodium hydroxide up on top for every 1 mole. And when I do that math, moles of sulfuric acid cancel. I'm left with moles of sodium hydroxide. And when I do 1 times 2 divided by 1, I end up getting the answer of 2. What does that 2 represent? It represents moles of sodium hydroxide. Okay, so now I know I have 2 moles of sodium hydroxide. That's awesome. But how does it eventually get me to the volume of the base? So I now know how many moles of sodium hydroxide, and I also know its concentration. So can I use that to benefit me? And yes, I can. If I know the equation for molarity, which I do, the molarity of the base is going to be the moles of that base divided by the liters of it. Now, I already know 2 of those 3 things. I know its molarity, and I know how many moles, so I can solve for the liters of it. So let's plug that in so that I can eventually get my answer for liters of sodium hydroxide. Okay, so first of all is moles of the base. That was given to me in the problem. That's 1 molarity. Boom. What about moles of the base? I just solved for that over here. And that was 2. So I'm going to put a 2 up on top. Now, the bottom number is what I'm solving for. I'm solving for liters of the base. So that's going to be my X. All right? So when I solve for X, I don't know how you want to do it. You want to do cross multiply. So it's going to be X times 1 equals 2 divided by 1 on both sides. In the end, X equals 2. Now, goodness gracious, look at this mess in front of us. But what does that mean? Well, the 2 left over, remember, was for liters of base. So that means when I was solving, liters of base is liters of sodium hydroxide. So I finally figured out what I needed. Holy smokes. I need 2 liters of sodium hydroxide for every 1 liter of sulfuric acid if they both happen to be a 1 molar solution. Okay? So wow, looking back at that, there were quite a few steps. But in the end, let's just focus on what really happened. We only used 2 equations. We used the molarity equation for the acid, and then we used the molarity equation for the base. The only individual step we had to do in the middle was to convert moles of acid to moles of base. And to do that, you just use dimensional analysis, okay? Hopefully this helps you out, science friends. And if you have any questions, just reach out and let me know. Be well.